Welcome to the data metaphor space. First of all, please invite our two guests, Mr. Kakashi and Ms. Catwoman. Before the show starts, please ask two guests to say hello to the audience. Today, our theme is how to use an array or linked list to store a large number of user names.
Earlier we discussed the query and insert operations of arrays and linked lists. Now, what if you want to delete the element? Linked lists are also a better choice, because you only need to modify the address pointed to by the previous element. When using an array, after deleting elements, all subsequent elements must be moved forward. Unlike inserts, deleting elements can always succeed. If there is not enough space in the memory, the insert operation may fail, but the element can be deleted in any case. The following is the running time of common array and linked list operations.
As we mentioned earlier, linked lists are good at insertion and deletion, while arrays are good at random access. Often users register on Facebook. It is said that the total number of Facebook users is more than 2 billion, which is a huge number, accounting for about 1/3 of the world's population. Suppose that Facebook records a series of usernames. Whenever a user tries to log into Facebook, it looks up the username and allows the user to log in if found. Since users often log into Facebook, a lot of username lookup operations need to be performed. Suppose that Facebook uses a binary search algorithm, and this algorithm requires random access in order to be able to immediately obtain the middle username. With this in mind, should you use an array or a linked list to store usernames?
Well, assuming I have decided to use an array to store usernames, what are the disadvantages of arrays in terms of inserting? Specifically, what happens when a new user is added to the array?
In fact, Facebook uses neither an array nor a linked list when storing user information. Suppose that Facebook uses a kind of mixed data, an array of linked lists. This array contains 26 elements, and each element points to a linked list. For example, the linked list pointed to by the first element of the array contains all usernames starting with A. The linked list pointed to by the second element contains all usernames starting with B, and so on. Suppose Alan is registered with Facebook, and you need to add it to the aforementioned data structure. Therefore, you access the first element of the array, then access the linked list pointed to by that element, and add Alan to the end of the linked list. Now suppose you want to find Zuckerberg. So you visit the 26th element, and then look for Zuckerberg in the linked list it points to. The linked list contains all usernames starting with Z.
Compared to arrays and linked lists, is the search and insertion speed of this hybrid data structure slower or faster?
You can try to think about it. Which one is more used, array or linked list? Obviously it depends on the situation. But the array is used a lot because it supports random access. There are two access methods, random access and sequential access. Sequential access means reading the elements one by one starting from the first element. Linked lists can only be accessed sequentially. To read the 10th element of the linked list, you must first read the first 9 elements and find the 10th element along the link. Random access means that you can jump directly to the 10th element. In many cases, the read speed of arrays is faster because they support random access. Many situations require random access, so arrays are used a lot.
Thank you two guests for the discussion and sharing today. Let's see you next time.